Okay, so in the last video, we investigated the selection sort algorithm, and I challenged you to try and write the code to sort a random array of ints using the selection sort algorithm. So here is the solution here. The method header, of course, is going to be void. Nothing's being returned, and it's going to accept an array reference. Specifically, this one's going to be an int array reference. So that means that this reference must point to an array of integers. Okay, so we're going to make a loop where I starts at 0, and I is going to go up to 1 less than the length of the array. So if I still have that note over here, yeah, the selection sort, we learned that I is going to start at 0, and it's going to go up by 1, and it's going to go all the way up to 1 less than the highest index. Okay, so that is why we have the -1. If you don't have the -1 there, it's no big deal. It's not going to crash. It's just kind of a waste of time to compare one element at the very end. And we already know that it's in its proper place. Okay, so then in the loop, it's actually quite easy. You can do this with one line of code, but I split it up into two. So I'm just making a variable x that's going to store the index of the minimum value of the array, starting at index I. So if you recall, we made we modified our find min method to have this start parameter. So that's very beneficial for the selection sort algorithm. That allows us to start our search at a certain location. And then I'm going to store that index in x, and then I'm going to swap the elements at indexes x and I. Okay, so x once again is the location of that minimum value, and then I is the little pointer at the beginning. So if I look at this note here, I is this little placeholder, and then x is the index of the smallest value in the array. Okay, so then we're just constantly swapping the elements at index I and index x. Okay, so hope that makes sense. What's really awesome here is if I wanted to overload this method for strings. So if I had an array of strings, just change my comment here. All I have to do is change this to a string array, and all the code will work. This will work. Now that's assuming you have a find min method that accepts an array of strings. So hopefully you have a second find min method that takes in an array of strings. And remember, we use the compare to method in order to compare two strings. And then of course you also need a second swap method that accepts an array of strings, and then this little temporary variable needs to be a string. Okay, so that should work. I created a separate class called testing selection sort. So in this class, I created a 25 element array of random ints between 1 and 100. And then what I'm doing is I'm printing the array first, then I'm sorting it, and then I'm going to print the array again. Just one thing to remember, that this command here, this does not print the array at all. It just sorts the array. So it makes a series of swaps really, really fast. And then when this is done, my array nums should be sorted. And so then I'm printing the array again. So let's have a look and run this and see what we get. So we get our 25 element array of random ints, and then right after it, it's the same array, but the values have been sorted in ascending order. See, the original array has 2 4s, and this has 2 4s right at the beginning. So everything seems to be okay. All right, so there is another classic sorting algorithm. There's actually lots of sorting algorithms, but two of the most classic, kind of the oldest sorting algorithms are selection sort and another one called bubbleSort. Some of you may have heard of it before. So today I'm going to try and get you to write another sorting method, but it just sorts it in a different way. And this is called the bubble sort algorithm. Now, again, bubble sort is not very fast when you have a large array. So selection sort and bubble sort are kind of easy sorting algorithms to comprehend, to understand, but they're quite slow compared to some other sorting algorithms. We are going to look at a really fast sorting algorithm in the next unit, and that's called merge sort. So that merge sort is quite fast, but it's quite complicated to code. Okay, so how does bubble sort work? Well, it's pretty easy. We just look at the first two values, and if the first value is greater than the second, then we swap them. So 23 and 15, we're going to swap. Okay, then you just look at the next two, and you do the same thing. If the first value is bigger than the second, then we swap. But it's not, so we're going to leave it alone. And then you look at the next two. If the first value is greater than the second, we swap. And if not, we just leave it alone. So we're going to leave it, and we're going to look at the next two. Okay, if the first value is bigger than the second, yes it is. So we're going to swap 42 with 8. Okay, so repeat this process. So 42 is bigger than 17, so we're going to swap. And one more time. This time we're looking at 42 and 25. Yes, 42 is bigger than 25, so we're going to swap 42 and 25. Now, if you look at the array, it's not sorted. But what we have done successfully, we have bubbled the biggest element to the end of the array. So we kind of picked up the biggest element and bubbled it to the top of the array. So it's in its proper spot. So now what we have to do is go back and do this again. So we have to go back to the beginning and do this again. So is the first value bigger than the second? No. So we do nothing. And then we look at the next two. Okay. Is the first value bigger than the second? No. So we do nothing. And okay, is 31 bigger than 8? Yes. So we're going to swap 8 and 31. Okay. And then we're going to, oops. We're going to look at the next two. Yes, 31 is bigger than 17, so we're going to swap. Okay, and then we're going to look, We're going to look at the next two. So 31 is bigger than 25, yes, so we're going to swap. I forget, what was that again? That was a 31. Okay, so 31 swapped with 25. Okay, now you can stop. On the second pass, you don't have to go all the way to the end because we already know that that 42 is in its proper spot. So the second time through, you can go one less through the loop. Now we have to go and do this again. So we're going to start at the beginning. And we're going to do this again, but again, we can go one less than the time before. So 15 and 23, no, stays put. 23 and 8, we're going to swap. 23 and 17, yeah, we're going to swap. 23 and 25, no, we're not going to swap, and then we can stop. We don't have to compare these two or these two. Now we're going to go back to the beginning. Again, so 15 and 8. Yes, we're going to swap 15 and 8. And then 15 and 17, no, we're not going to swap. 17 and 23, no, we're not going to swap. And then you can stop and go back to the beginning. Now, it turns out that I'm already sorted. But you can just carry this algorithm through to the end, and then you should have a sorted array from lowest to highest. So this code, you might find a little bit harder to do this code. As a hint, you're going to need the swap method. So you're going to call the swap method. You don't need find min for this. And you need a loop inside of a loop. So this is kind of what makes this difficult. You're going to need a loop, and I recommend making I in the first loop. And then you're going to need a loop inside of that one. So I won't give you the answer here. I'll let you try and figure it out. but you're going to have a loop inside of a loop. And you're going to call the swap method inside. You're going to have an if statement, and then you're going to call the swap method if something is true. So I'll let you try and figure that out. So once again, this bubble sort method is going to be void, so it's not going to return anything. It's going to be similar to selection sort in that way. You might look at this and you might say, wow, this is a lot worse. This has got to be slower than selection sort because there's a loop inside of a loop. But don't forget that selection sort also has a loop inside of a loop. You just might not have seen it. So if I go back up to selection sort, you just see one loop here, but remember that find min actually has a loop inside that method itself. So it really is a loop inside of a loop. So they're somewhat the same efficiency, selection sort and bubble sort. It's just that in selection sort, this inner loop is hidden within the find min method. Okay, so I'll let you try and code the bubble sort and then test it. So maybe make a class called testing bubble sort and make a random array and see if this works. And then you could probably even compare the speeds of bubble sort and selection sort by making really large arrays and testing them out. Okay, so that's it for now. Thanks for watching, and we'll see you in the next one.